Hey, hello, everybody. So, all right, so let's get started. Hi, hello. So, yeah, I think there's the big thing that has happened last week is KubeCon. So, WasmEdge, there's actually, I would say, 6 talks about WasmEdge at the big conference, and from us, from myself, from Vivian, and also from our community in India. There's about AI inference, about how to what is WasmEdge, how to use it in the microservices with Dapper, with Docker, and so I talked to a lot of people, and so the focus of this community meeting, we want to talk about the container tools, because that's one of the big announcements that's coming out of KubeCon. So there's only 2 agenda items here. I think both are demos for this community meeting, and I'm gonna start, and then the next one would be Sven from Liquid Reply, that's who has done excellent work integrating WasM with Podman, which is RedHat's version of Docker, right? Docker command line. And I actually have spoken with people at RedHat and OpenShift, and they also have they were excited about that, and they have plans to to integrate WasmEdge further into the OpenShift ecosystem. So we'll have that conversation maybe later this week, and we'll probably have something to report in the next community meeting. So that's the second half of this talk. Sven will demonstrate what he has done with I think it's called KWasm, right? That's and how to integrate WasmEdge into Podman, and how to make that workflow better. And in the first half of the talk, that I'm going to start, and we're going to focus on the collaboration we have done with Docker. I met with Docker, I think several months back, and at the time I didn't have much expectation, because I didn't know what they want. That's because in some way, some people thought that we were competing, right? Because that's we both have a sandbox format or isolation format, but turns out it's not. That's turns out they have a much more open open view towards the world than I originally thought. So they were very open about adding new runtimes into their developer tools, which is a Docker CLI, and so it comes full circle. As the Docker people say, that's so. What I'm going to do first is that I'm going to give you a demo in how WasmEdge works in Docker, and there's a full talk about that in Cloud Native Wasm Day, and Vivian, can you put the link to the YouTube video here? And I was there's lots of I think the talk is well done. If I can say so myself, it's on Cloud Native Wasm Days, given by myself and Docker's Director of Engineering, Chris Chrome, and that's it talks about why we did the collaboration, and it's the idea is really to provide more tools for developers, and how the collaboration is done, right? Which is the basis of the demo that I want to show you in the next couple minutes. And yeah, so that's why did I say it goes full circle? Is because when we started WasmEdge, it was inspired by Solomon Hayek's, famous tweet in 2019. So he has a pair of tweets. That's most people only know the first one, and great. So the YouTube video of the talk is in the chat now. So where you can also put Solomon Hayek's, 3 tweets in the chat as well. So the first one is really the famous one when he said, if WASM existed in 2008, we wouldn't have created a Docker. WebAssembly on the server is future of computing, right? That's it's basically it's a manifesto. It's that's it's about server-side WebAssembly is about to take off. That's the idea. So that's but then he followed up with the second tweet, because then people ask him, that's as a Docker founder, when you say this, does that mean WebAssembly is going to replace Docker? And that's 2019, right? And he immediately replied, that's not what he saw. The idea really is that we're going to live in a multi-container world. Linux container would only be one of them. There will be Windows container, and there will be different operating systems, different CPUs, and WASM is one of those things that's that are gonna be in the world in the future, right? So he mentions a multi-container world, multi-runtime world. And after all these years, and I think last week he tweeted again and said, and he has now left Docker, right? He has a new company called Dagger. That's a separate conversation. It's also very interesting. If you guys have time, you can check it out, called Dagger.io. It's a CI/CD company. It's a new framework, right? But the point is that he has left Docker, and he tweeted again and said, that's essentially, that's the vision from 3 years ago has been realized. We're finally living in a world that is multi-container, right? That's so Docker itself has now support not only just Linux container, which they originate from, but also WebAssembly in the form of WasmEdge. So what is this multi-container world? I think we have talked about that in our writings, but I think this with this Docker announcement, and I also think with Sven's work at WasmEdge, is that you can now use a tool to start up an entire application. The entire application could have multiple microservices, could have databases, could have load balancers, could have sidecars, could have a lot of those elements, and each of these elements would run in its own container. And in the past, each of those containers is a Linux container, but now you can use different containers for different workload, right? So the database is probably gonna still run or at this moment would still run in a Linux container, or anything that is long running, but things that needs to scale up and down very fast, like microservices, like serverless functions, and things like that, can now run on its own WebAssembly-based container, and it could be managed by the same tools. It could scale up and down really fast. You could spin up 100 web services instances to serve behind the load balancer or connect to a database within milliseconds. Instead of that has brought profound changes to the architecture itself, because in the past you would have to because the container is it's slow to start up the container, so you will have to keep those things warm, and you will have to have architecture considerations to essentially to have them running as long-running servers, and then have a strategy to scale up and down, and things like that. But with a new world of mixing long-running containers as Linux containers with perhaps short-running but can quickly scale up and down containers in WebAssembly, you can really design new types of architectures, and especially around microservices. And we really look forward to that. That's also so I would jump ahead to say that's also part of our talk with Dapper, because Dapper has a microservice framework, and it has a sidecar architecture. So there has been a lot of talk about, I gave a talk there, and they're going to also come to our developer event next week in Silicon Valley, is to talk about the Dapper sidecar to run in a Linux container, and then it can drive a lot of microservices that runs in a series of WebAssembly quote-unquote containers. But there will also talk about maybe the Dapper sidecar service itself could be compiled into WebAssembly and run in WebAssembly, right? That's all. That's a Microsoft project called Spider Lightning, and which also is fascinating. That's so it provides a lot of like key value store, like messaging queue, and services like that, and it can be entirely compiled into WebAssembly. And in that scenario, you can really have those services, all live in WebAssembly and communicate to each other. So yeah, that's what I want to say is that's super exciting. And so you have several links in the okay. So let me get started with the demo. Let me log into my machine first, my remote machine. Okay, let me share my screen so that you can see what I'm talking about. Let's see the Google screen, the browser screen first. So this is the product page, right, for lack of a better word, for Docker plus Wasm, and that's so they basically released. So the simplest example, way to do this is to follow instructions on this page. Although we would do something else, but I'm going to talk about that in a minute. So it's all based on the Docker desktop, a preview version of the Docker desktop. So you can install it for your platform, and you can download it for your platform and install it. And after you install it, you would have be it Linux, Mac, or on Windows. I believe you need the WSL, the Linux system on Windows, and so then there's a series of examples that you can go through, right? So they have published some Wasm images. The way it works is that it's a container D shim. So because underneath Docker it uses container D, and right now when you run it, you still have to specify the runtime equals to this, meaning that's explicitly tell it to use this container D shim to run this image. But I think, but one of the goals that we have, that's I think that be in the near future, is for the tool to automatically detect the platform. So so that's actually a little different from how we did it in Xeron, is that when the platform is WASI and WASM32, it would know that it can't use a Linux container to run it, because there's no Linux container on this Wasm CPU or a Wasm platform. So you would have to use a Wasm runtime to run it, namely WasmEdge, right? So I think in the next iteration you could automatically do the automatic detection. So you can go through this example, and one of the most interesting thing is Docker Compose. So I don't know if you guys are familiar with Docker Compose. I think it's an incredibly useful developer tool, because if you spin up, of course you can spin up or orchestrate multiple, containers with Kubernetes, like we do with Xeron under Kubernetes. However, it's kind of tedious, it's kind of overkill, for development work to just to use Kubernetes. And Docker Compose I think it's much more developer friendly. It's easier, so you can have a YAML file, configuration file, to tell it how you want to start those, how do you want to build and how do you want to start those containers. And then with Docker Compose build, you can build everything with Docker build everything in containers so that your machine doesn't need to install dependencies. In our case, your machine doesn't even need to install Rust because it fetches a Rust container and build an application for you. And then Docker Compose Up would spin up all those containers, and you would have the application running with a single command, right? So yeah, that's and then this example, which is by the way, which is an example we showed in last community meeting. It's a microservice written in Rust and connect to a MySQL database. So it's entirely complete HTTP-based microservice written in Rust and compiled to WebAssembly, so it can run on WasmEdge. So they demonstrate this example. They build it and use Docker Compose to start up database, this service, and then a web server, and then have the whole thing running. So it's I think it's a very elegant experience for developers. Yeah, so that's you can read through the whole document. There's lots of information, but I want to show you something that is slightly different, because not everyone wants to install Docker Desktop, right? For a lot of us, we use Docker command line. That's how do we do that? I think you can go to this example on our repository, which also has detailed instructions on how to build and how to run it. It basically tells it has Docker file, and you can see, if I open the Docker file, you can see this. There's part of Docker file that is built, right? It installs Rust and in a container, and then use that container to build. And then it's after the build work is done, it creates a new container. That is container image that is very small. It's come from scratch, and all it has, it doesn't have Linux in it. All it has is the build artifact, the WasM file in it, right? So it's it knows how to build it, and it has Docker Compose to show you, those three services I just mentioned, right? Three services you can spin up the database, the application server in WasM, and then the web server for the starting web page. So so it has all the information. And if you go to the quick start with Docker guide, there's this install Docker Desktop tells you where to download the Docker Desktop, which is the same links as we showed in the previous page. But the interesting link is Docker CLI plus WasM, which is where Chris has created a GitHub repository. It goes to this link, install Docker engine with WasM support. So you do need to install Docker first, and Docker Compose, which is a Docker plugin. But then it tells you to go through all these steps to build a container DSham. You can see all the internal workings of this. Just to follow this step by step. It requires you to change configuration files, and then you can start container D in your system, and then you can run Docker Compose. So let's go through this demo. This is let me get this command first, and then share my screen to. Hold on. There we go. All right, so you guys can see my terminal, and so this is on the remote machine on Azure, right? This is a VM, and this is the new Docker D that they have built. So Moby, in the instruction earlier, so I have already built it. That's according to those instructions. Where is it? Yeah, install WasmEdge, and then check out Moby, and then check out the WasmEdge branch of Moby, and then make binary. So that's it, right? So now it's time to start it. Oh, sorry. Yeah, that's so I just ran the command I unintentionally. So you can see it's a sudo shell, right? What the shell is it starts the Docker daemon. and connect to a Unix socket file, and with data root and things like that. And what it does is that it starts Docker-D with the container D shim that's built into that. And we can see in our system, we already have container D shim installed, I believe it's here, yeah. So we have WasmEdge installed in the system directory. And we built and installed the container D shim WasmEdge v1, which is also in the instruction. It tells you where to download it. The download file is a zip file. Just download it for your platform and unzip it, and put it here, in your system path, user local bin. So now we have Docker-D started, and the Docker-D knows where to find the container D shim, and the container D shim knows where to find WasmEdge. It's not the WasmEdge command line, but the WasmEdge library, so that it can start all those services, right? And we start all this in the backend. So that's basically it. That's you. And the instruction also tells us to create a new context, so that we don't have to do those configurations every single time. But that's I think I believe I already did that. So Docker contexts. Sorry. Is that how to? Yes. So it has a default context, and it has WASM context. The WASM context connects to docker.sock, which is here, right? So we now have Docker set up to use this version of Docker-D by default. And if you want to go back to your original Docker experience and you don't want to use the preview anymore, you just to change your Docker context into default, and it would go. I thought that was very interesting. It's like a lot of tools are set up like that, so you can just switch context, and it would change the environment entirely for you. So now we have, but here essentially we have this, we have the Docker-D environment that's set up. So now we can go through the tutorial and run our application. And our application is in second state, and this right here. So like I said, there's a Docker file, there's Docker compose, and if I do Docker compose build, it would fetch because this is a new system. I don't think it has cache, so it may take a while. Yeah, so basically what it does is that it's gonna set up the build environment and build this, because there's only one thing to build. That's our microservice, right? So it's gonna build our microservice, which contains HTTP server and a database connection and the logic in between, all those into a WASM file. And then you can, and then, it's gonna take a while because the build command is, the toggle build is really slow if you don't have it pre-cached. But but at least this is on a fast network. So let's wait for it to build. I have another terminal which I can show you around, and so let's go to this demo directory. Let's see what it. Oh, sorry. So this is a Docker file I just showed you, right? So essentially it's it's very much like GitHub Actions. It updates your Linux, installs Git clan, and installs WasmEdge, and then it's built it, right? That's and then this command is use WasmEdge C to build the once you use cargo build. Where's cargo build? Yes. So here's cargo build. So you use cargo build to build a WASM file, and then you use WasmEdge C to do the AOT compilation, because now you are ready to run it in the container, right? You already knew where your target platform is, so you can run it. And then the real Docker image that you can publish is really this one, just the WASM file in it. And this WASM file is already double the size, because we did the AOT compilations. We have a machine code in it as well, and we can make it half of this size, if we want to. But but this is but we also want better performance, so we put it here. So it's building. Okay, so cargo is building here, and we can see the source code. The source code is just one single file. It's a main function, right? So if we go here, it's only 259 lines of code, and the main part is really this. It has, it's an asynchronous main function. It does two things. First, start a connection pool. It starts a connection pool into a database. So it assumes there's a MySQL database that exists outside of it. So it starts a database pool. And then it's start listening to at the 8080 port on the local host. And every single time there's a request coming, it calls a function called handle request, and passing the request and the database pool. And now you go to the handle request. You go to this function. You can see this. By the way, this is Rust, the Tokyo and Hyper framework. So that's it's simple because the framework did all the work, right? So you can see, you can check, what's in the request URL and the method. If it's just goes to the root URL, you would see the valid endpoints are this. And however, if you have, say, init, then it creates a database, and so it has those database operations based on the Rust struts, right? So but I think also interesting is that it gets a connection first. The connection pool has 10 concurrent connections into the database. It's a single thread, but multiple concurrent connections. And so you can get a connection from the pool, and then, and then operate on it. Those are all, how you do SQL statement in Rust. So I think it's done now. Okay, I think it's done. So it has built everything. And let me see. Huh? Okay. Let's see what it's generated. Okay. So it starts now. It now has three containers really. The first one is MariaDB, is a database. It's 100 megabytes. Okay. And then the second is a very stripped down Nginx. It's 10 megabytes. This is just a database server to serve a static web page, right? I'm putting it here just for demonstration purposes, because this static web page can be served anywhere. It can be on blockchain, because all it does, it has JavaScript to connect to the backend microservices through HTTP connection, right? Even that is 10 megabytes. And then the server is what we build from the code I just showed you. Is 3 megabytes, okay? So this server contains HTTP server, which is essentially what Nginx does, and it contains a database connection, database client, and it has all the logics that sits in between, to what's the database schema, what's the model, and how to create the database, query the database, and things like that. So it has all three of those. And now we get all of them started up to say Docker compose up. Okay, so I think that's it. Yeah. And the important line I want to show you, after you do Docker compose up, the application server starts first. Where is it? Okay. Well, I can't find it, but I can do it here. So let me see that. So one of the first thing I do is I want to see if this thing is running. So I will just do a curl. Okay. So remember, the handler function I've showed you, right? If I just do the the root directory, it would come back with a message to tell me what's valid command. So now I can do the init command, which is this, right? I just do HTTP GET to the IIT command. The status true. It means it's actually I will show you this. Why do I have to? Okay. So you can see those three containers running: Linux container, WasM, and the WasM has port number mapped, right? So I go to the localhost 8080. I send a request into this WasM server, and this WasM server does all the work. And so here now I have init. I have I have created. If you see the the code I just showed you, the init command does create database table. So it creates from the empty database, it creates a table with the schema that we want. So now I can do create orders. Let me show you what's in order. Let me show you what's in orders JSON. So the orders JSON is a bunch of orders based on the database schema we just created, right? So I can do create orders and return true. Now I can ask the database to return me the orders. Yeah, so that's the JSON data we just feed into the server and then get written into the database. So this is a round trip. I just got it back, and I can do delete order. Now you can see, although I know it's hard to see, order 1, order ID 1, order ID 2, which see this thing, right? There's a record here. It's 1, 2, 3, 4 before it goes to order ID 3, right? So now I do this. Oh, sorry. Let me do the delete order command. I want delete order number 2. Okay, so I do the orders again. Now it's order ID 1. The next is order ID 3, right? Order number 2 is gone. So that's that's a very simple example. And we have shown people quite many examples, including fairly complex database examples and AI inference and things like that, and they all work. So that'd be my demo. That's it's almost 40 minutes now. So again, let me go back to share my Chrome. Okay. I think the best URL is this: the second state microservice --rust-mysql. This is if you have from the application server world, Java world, or microservice world, this is a very familiar demo. It's write everything in write an application server, compile the application server, run it in a container, and interact with other containers. Like one other container on the front end is a web server container on the front, which can also be a load balancer. Can do a lot of things. And on the back end, it's a database server. So that's the whole 3-tier architecture. It's very standard and very, I think, very easy to understand. And it has links on how to install those tools. And with a single Docker command, if you use Docker, that's essentially all you need. That's after you install this, you are done. You can go, like I have just shown you, right? You can go all the way to the test section, and start interacting with it. If you don't install Docker, then you will go through the install Rust, install WasmEdge, in order to build it and in order to run it, and then and then you reach a certain point, right? So I think really, in my view, this integration really makes it a lot easier, and a lot easier for us to ship our products, right? For our developers to ship their product, because you don't need a very long set of instructions to tell people, how to build it, how to run it. That's so just tell them Docker compose up. That's it. So I really look forward to for Docker to to have a. If we go to the Docker.com website, that's what they talk about now. That's this is official website. This is their homepage. The logo has changed to Docker plus WasmEdge. I thought they're gonna do something at Halloween, but I guess not. So and this is a link I just talked about. So there's you can easily find those resources, and the how to use with the CLI is a little hard to find, which I just showed you. And and then our repository has all this information and also has sample code you can play with. Just fork the repository and play with it yourself. And yeah, that's all I have to say here. And so I'll pass this over to Sven and ask him to show what's happened with on the Podman side, which I thought was also super exciting. I'll stop share here. Hi, Sven.
Hi, Michael. So it was so great to see you all at KubeCon. So I've seen your talk and I've seen Vivian's talk, and was yeah, so totally cool, like a community meeting, but much bigger. And so I'm also totally amazed what Docker has done here. And as you said, it's not just like, look what it's possible to integrate WebAssembly. It's like, can you see my screen?
Yes, yes.
They have changed the logo. They have announced it everywhere. I've seen it on Hacker News, even if not on the top page so long, but it was there. And yesterday I found this announcement, a feature that I've long missed. You can not only now push images to Docker Hub, but you can also push hand charts and WebAssembly modules without containers. So just the module and download it from there. So they are, I would say, really sold on WebAssembly. That's a very nice thing.
Yes.
Okay. What I want to talk about is, you mentioned a few times Postman. Yes, we have done a Postman demo, but it's not mainly about Postman, it's about Kubernetes. So we are Kubernetes experts. In the KWasm repository, you can find the Postman example as well. If you have seen the instructions we are going through right now, it's nothing new to you. So it works pretty much the same with Postman. But here we are talking about Kubernetes in general. That's me. Hi, I'm Sven. You can find me on Twitter, LinkedIn, GitHub, and lately on Mastodon as well, but that's another story. Let's talk a bit about why Kubernetes needs WebAssembly. So a very important thing for Kubernetes systems is the startup times of applications and the size of containers. So no secret there. The longer it takes to download the image, the longer it takes to start an application, even if the image is usually only downloaded once per node. But that sums up for different applications and so on. So WebAssembly images can be even theoretically be smaller than distro-less images. Because the runtime is already there and you don't need to ship the runtime with the application. You have a faster startup, you have lower network traffic. WebAssembly, as you know, is platform independent in that way that if there is a WebAssembly runtime on your platform, you can run your WebAssembly modules. You don't need separate container images for different processor architectures anymore. You can use one container image, run it on your cluster, even if you have a node pool that has mixed platforms. And you have another layer of security with your WebAssembly runtime. So you be a bit more safe in terms of container escapes because the WebAssembly runtime takes care of the runtime security. Other way around. Why is Kubernetes beneficial for WebAssembly? So Kubernetes is a proven solution to scale applications, to orchestrate different parts of applications. And every cloud provider has a Kubernetes offering. So at the moment, there's only one cloud provider who has a Kubernetes offering that can run WebAssembly. And that's a bit limited. And if we can run WebAssembly direct on Kubernetes, then all cloud providers would be able to run our applications. Kubernetes has a good adoption in enterprise and vibrant community and a huge ecosystem that can be leveraged. There's the mandatory link to the cloud native landscape. WasmEdge is here, so we are here, but we can integrate with all other parts of the landscape if we have a good integration into Kubernetes, and then the ecosystem works for us. Okay, that is where KWasm comes in. So we have 2 points that are important for the project. It makes it easy as possible to try WebAssembly on Kubernetes, and we want to meet the developers where they are. They don't need to learn new tooling. They don't need to change something. They just need to use Kubernetes and can run their WebAssembly applications there. It's exactly what Docker is doing. So no new tooling, but new possibilities. And it's the, I would say, next step after you have created your image with Docker. You can test it and use it on development machine with Docker Compose. And then you can go to the cloud vendor and say, okay, I want to have a Kubernetes. I want to run it on huge scale rollout, and you should not need to have any change to your local setup. Okay, official warning. So this project is really at an early stage. We try, of course, our best to not damage any nodes, but even if we have tested a lot on new setups where this application have never run before, it can crash the nodes, and therefore we advise to always use a fresh cluster. So go to a cloud provider, create a new one, use a local cluster and create an empty cluster, test what you want. You can do whatever you want, and then tear it down and you're clean again. So it's definitely for development and evaluation purpose. It's nothing you want to run on productive systems right now. Last advertisement for this presentation. If you are looking for a solution that is really ready for production, reach out to us. We are really interested to work with you together and find a way that really works. But this project is meant to work on so many different Kubernetes versions that it's just not possible to make it safe in an, I would say, it would simply cost too much to make it safe, and the demand is not there. So testing, very good thing. And now what can we do with it? We have just limited it to Debian-based Linux systems that use containerd and run Kubernetes. And you would be surprised how many Kubernetes distributions are still matching this criteria. So we support the CRUN installation for WasmEdge and the containerd shim, but not for WasmEdge. It's just in the making. So it was just a bit too new for me to integrate it to this meeting. So we have a look at how to run with CRUN on Kubernetes. And the distributions that match this criteria are by now Minikube, MicroK, Kubernetes in Docker, Azure AKS, AWS EKS, and GCP GKE, but both only with Ubuntu nodes, and DigitalOcean Kubernetes. So I would say that's a lot there, that we only have one way of installation implemented yet. Unfortunately, there is no way to do the same with Oracle's cloud and with OpenShift, because they are not always using containerd and different Linux distributions. So we need to adapt it a bit and haven't done that yet. So it's not that we don't want to use it. We just had not the time to adapt our installation process to that. The installer can be applied on two different ways. I would say, old way is just use the installer with a daemon set. That means all nodes are provisioned at the same time. At the end, there is a leftover pause container on every node. And the advantage is you don't need additional install steps. So it's, I would say, a very fast way to get up and running. But since you provision all nodes at once, you have the problem that if the installation process may crashes your node, all are crashed at once. So what we came up is the KWasm operator, which is just a very simple operator written in Go with the operator framework. My dear colleague Max Schmidt has done that. And there you can annotate a node manually and say you want to provision that node with WebAssembly and WasmEdge. And then the job starts, provisions the node, and after the job is done, it's stopped. So you don't have any leftovers, and the node is annotated as here is installed WasmEdge. That means you can schedule your workload more fine-grained, and you have complex setups like multiple node pools where only one node pool has WasmEdge installed. Okay, how does it look like? Let's have a short look at a listing here. So, is it readable? I can try to make it.
Yeah, it looks good. Yeah.
Okay, so what we are basically doing here is creating a new empty cluster. Here we add an Helm repository. We apply the installation of the operator. I already have the repository installed. I already have created a kind cluster. So what I'm doing is now installing with Helm the operator. And what's happening? Okay. Next, I'm annotating all nodes at once. Okay, I could do it one by one, but by now I know that it's working. And next thing is create the crun runtime class. Where's the problem? There is a space missing and line break missing. Ah. Okay. Live demos. Way.
Yeah.
So, okay. Next thing is just create our standard example. So it's just show that there's something that can be run. So the WasmEdge example WASI. It started, it's created. Usually it directly completes. And if we see the logs, we can see, hey, it was running, everything is fine, amazing. But doing that with kind is not that interesting, I think. So I have the same demo with Kubernetes on DigitalOcean. So I use the doctl here to create the Kubernetes cluster. And it won't be a surprise for you, but it works exactly the same way. So you install the operator. Cannot reach use. Of course, I'm still on the kind cluster, and just quickly need to switch to the DigitalOcean cluster. Fortunately, there is another listing for me. Okay. So let's install it. Let's see what's happens. Kubernetes. That should work. Oh, that's really sad. So I already installed it on the DigitalOcean Kubernetes. So you don't have seen the kind integration. So we could do it on kind again, but I would say you believe me that it works. So it's exactly this is my DigitalOcean cluster. You can see it here that my user is DigitalOcean KWasm admin. And here you see the jobs that I have installed WasmEdge on this node and are in completed state. So unfortunately, demo is over. So thank you. And if you have questions, yeah, feel free to ask.
Yeah, this is great. Then let me, jump on the first opportunity to comment. That's I love those short demos because it shows how simple it is.
Yeah, that's the idea. Show how simple it is. So just to wrap up, it's not meant for production, but it's the easiest way to get started with WebAssembly on Kubernetes. Yeah, it's the easiest way that at least I'm aware of to run WasmEdge on local test clusters. And for me, it's the only way that I'm aware of to run WasmEdge in managed clouds, even if you can ask how managed a cloud is where you add additional components, but that's another topic. Yeah, so the container shim WasmEdge support does just need a bit polishing. It's not working right now. And we are working on demos, examples, and documentation. What is working already is the Family Spin container shim. And yeah, just try it. We would be happy to get feedback. And if there are some problems, just reach out to us. Thank you.
Excellent. Thank you, Sven. Yeah, that's, I think, because we have also maintained an example repository for how to use Serum. We know how much work it is. It's to get all those things working. So really appreciate your help. And I think now the KWasm repository and project that you maintain seems to be really useful. We should all collaborate here. That's congratulations. That's excellent work. And so, one of the things that we wanted to do is to further develop the container shim, like you have just said. We essentially forked the wrong WASI container shim, and we are in the process of merge it back because we want the community to So the plan really is because the original wrong WASI was written by Microsoft DS Lab, so we forked it. And because we need this demo for with Docker, and now we are we are going to merge our change back to the original wrong WASI, and then our hope is that this shim can be merged further up to container D itself to become to become part of the distribution. That would make life much easier for all of us. So yeah, that's so I'm really glad that you that's you have got all those shims working, including the Fermion spin, which is also great. Yeah.
Yeah.
So yeah, that's
for
actually,
me. Right. For me, the spin shim and the WasmEdge spin are the most interesting ones, because in Kubernetes you need somehow network access to connect to your pods, and yeah, so therefore that's are the most interesting ones. And that, I would say, is a huge advantage of the C1 integration with WasmEdge. You can have different types of containers in the same pod. That is something that is with Container.Shim not possible by now. And it would be really hard. So that's a thing where you can have a Dapper sidecar, you can scale it with Kida. That's something outstanding at the moment.
That's excellent. Now I know what to tell the Dapper guys. So that's yeah, that's yeah, I really appreciate it. That's great. So there's a question in Jerome said, did you start talk to Red Hat for OpenShift integration? We started the conversation. I have a so they actually wrote an article on opensource.com about OCI integration, the C-run work. I had a meeting with them, and I'm going to have another meeting with them. But that's I think their interest is to have OpenShift operator. So is that something you have experience with, Sven?
With OpenShift operators?
Yes.
Yes, in general, we have, yeah, I would say, now a bit time ago, worked with OpenShift operators. But yeah, that's something we definitely can, yeah, work with.
Okay. Yeah. So Jerome, did that answer your question?
Yes and no. In fact, I was because I'm using heavily OpenShift, and I am using it for edge purposes, and because also I am new to WasmEdge, and this is something I am seeing as an evolution, natural evolution for things which are exposed to customer with the requiring very, very sensitive, latency sensitive workloads. So I am seeing that would be a real good match for all those criteria to have the KWasm ported to OpenShift for me, for the company I'm working in. So that was my question, in fact.
For KWasm, I have not talked to any of the cloud vendors, so most of them don't know that I just patched their managed offering. And for OpenShift in general, if I'm not mistaken, they are using Cryo as a CRI interface, and that's where the Container.Shim obviously cannot work. But the C1 integration works very well with Cryo, but I have not adapted it to OpenShift right now. So in theory, it's possible, but we haven't done it yet.
Okay, great, thank you.
Yeah, that's so. Yeah, Jerome, do get in touch. Because I think we are going to have this conversation with Red. We already had started the conversation, but but you have seen it's all those are being pushed by people who have use cases, right? So in the past couple months, Docker really had a use case. So there's an entire story that developed on that side, on Container-D side essentially. But on the CRIO side, that's and the Redshift, Red Hat, OpenShift operator and all that stuff. That's this. If you have need, that's something we definitely would want to support. Yeah.
Okay, great. Thank you.
Thanks. Yeah.
Thank you.
All right. So I know we're at the top of the hour now. That's any other questions? That's we should address in this call, or we can talk offline. I definitely would want to try out KWasm and all those integrations that that you guys have built. That's looks fascinating. Yeah. So
In general, we are around in the Discord, so just join the Discord and ask your questions.
Okay then. So I guess that's it. That's yeah. Malik, can you put the our Discord link there? So that if people want to join and talk to us, they can do that, and then we can conclude this meeting, and just go try out Docker plus Wasm, try out KWasm. That's if you have it, share with us your experience. And okay, so there's another question. Do you have any plan to come to Japan on December Open Source Summit? I'd love to, but we don't. That's yeah. That's hopefully we can be. I know there's also Cube Day in Japan, which I also missed. That's I also missed Cube Day in Germany. That's but I do hope to travel a lot more. In the new year, and including coming to Japan. That's I know Sven wants to come to Japan, right? That's the last time when we talked. That's we had a Japanese ramen in Munich. So we'd love to come, but but probably not in December yet. So we're gonna respond to those the open source those Japanese conference RFPs and try to get a talk accepted there. And then we would yeah, that's I met several Japanese bloggers, journalists, and also engineers at KubeCon. We had a really good conversation. So that's I really do look forward to meet our contributors and users in Japan real soon. Hopefully next year. Yeah. All right, so I think the WasmEdge Discord group has been posted in the chat, and if you're interested, just join us. Oh, okay. So I'm not sure whether we come to South Korea, but if there's conference, we love to go. That's pre-pandemic. I travel fairly frequently to Japan, Korea, but not really after the pandemic. I've only transferred, been to the airport, but not into the cities. So I really look forward to go again. Anyway, so that's I think that's it, and hopefully everyone enjoyed this, and go try it out, and thanks. I think we'll see you guys next time. Thanks.